Test. Okay, thank you guys for coming. Today we have Steve Yegge. A few years ago, he started a small blog that was mostly internal for Amazon, but then a lot of people started watching it, and he became famous and very controversial. So he's going to talk for maybe about an hour, and then afterwards, questions and answers. And I don't think he's a very sensitive guy, so odds are he'll offend you, and then you can get back at him at the end of the presentation or whatever. But he's probably not going to express his opinion too much. He's going to talk about JavaScript and other cool things. So without anything else, here's Steve Yegge.
All right, thanks. Hi, everyone. I got to make sure this works because otherwise the video won't pick it up. And we're videoing it to prevent me from telling you a bunch of confidential stuff that would get me fired. Pretty much is why we're doing that. So normally there'd be a huge crowd in here to see me because, you know, well, because. But the comic book Girl Genius guys are also talking at this time. So thank you for coming and not going to the Girl Genius one. I appreciate it. All right. So last time I was in this room, believe it or not, was about 5 years ago. Was anybody actually here in this room approximately 5 years ago, besides you? Yeah, so you may remember this. I was actually at Amazon.com at the time, and I was doing a recruiting talk. I was saying, come to Amazon, which that's what kind of they paid me to do. At this point, I would not recommend it, but that's what I was saying at the time. And, whoa, is the video turned on yet? Amazon's a great place. So anyway, we had this like mix-up where, you know, there was a job fair, and people were given their resumes, and like we got kind of a bigger stack of resumes than I expected. And in fact, we had such a long line of people wanting to come talk to us for God knows what reason, that it got to the point where we were like filtering them on the spot just to get them to go away. So people would walk up and I'd go, how's the hash table work? And they'd go, and they'd run off, you know, and it was great. But anyway, still, we got a bunch of resumes. And so, you know, so a bunch of people showed up. This room had, I don't know, 150 people in it. And so I called the recruiters and I'm like, you know, you guys only ordered like 20 pizzas. It's not going to be enough. You know, send more. And they go, is 50 okay? And I'm like, yeah, send 50. And there was some sort of mix-up, and they sent us 150 pizzas, right? And so, like, they just started just coming in with just giant stacks of pizzas. And so, of course, everybody had a pizza. And they're all just going, you know. And I just remember people coming up to me going afterwards, just covered in sauce, going, this is the best talk ever, you know. And I'm like, thanks. So anyway. So hopefully everybody's eaten and everything. So I proposed a couple of things to talk about today, and the fine ACM committee, I assume it's ACM putting this together. Of course it is. And they vetoed my first couple ideas as being not technical enough. So I'd like to kind of get a feel. Who here is technical? Now, who here is in CS? All of you. See? All right. So great. So I guess what they wanted me to do was talk about something technical. Hey, you don't have to leave. How sad. Oh, no. I scared him away. All right. So, yeah. Well, it's okay. All right. Just so you can raise your hand. Who here is not in CS? Yay. Hello, everyone. Who in here doesn't like to raise your hands, and so you didn't raise it before? Okay, good. All right. So they wanted me to talk about some of the technical. So I'm going to talk about, loosely, I'm going to be talking about this framework that I wrote at Google, and probably tell you a little bit more of the interesting stuff, like the politics that got me to actually write it. And we'll talk a little bit about compilers to make you happy. Who here is actually taking compilers? Small number, a few hands, good. All right, enough. So I'll talk a little bit about compilers, but I won't snooze it to death because that would be bad. And then probably I'll be done like in half an hour, and then we can like ask questions. But feel free to stop me if you're confused or if you want me to change subject or whatever. All right? I'm going to take my name tag off since you know who I am now, and it's bugging me. All right, so today we're going to talk about this stuff. We're going to talk about JavaScript. Ooh, JavaScript. Yes, and we're going to talk about Eclipse and how slow it is. I got to ask. I'm just done. A question already? All right, well, I'll talk a little bit about the compiler stuff. Yes, I will. Okay, so, all right. Who here, I just want to just kind of calibrate here. Do you guys know Java? Everybody knows Java. Do they like teach courses here in Java or something? I mean, is that the bread and butter, the sort of staple language? Who here knows OCaml? Wow. See, this is why I like UIUC. Like we used to seriously, Google is a Stanford company, right? Like the founders are from Stanford, and all the sort of the kind of old boys club of and old girls, including what's her name, Marissa. The sort of the VPs who are all buddies with the founders, early on. They're all from Stanford. They're right next to Stanford, right in Palo Alto. And Stanford is, in my experience, God, is a school that, unless you were with Jeff Ullman, okay, he's like the exception, a school that basically tells you that C++ is the fabric of the universe, right? That's all you need, C++. All those other languages are just, meh. And then we'll focus on algorithms and distributed computing and all this really cool stuff, but not languages, okay? And so literally, I get PhDs from Stanford, and they're like, yeah, I don't know why people have to learn all these other languages. All you need is C. And it's like, oh, good, they taught you what a Turing machine is. I'm glad, right? But why would you want to program in a Turing machine, right? And they're like, well, so unfortunately, that means there's this huge C++ contingent at Google, right? And as such, they think of themselves, you guys are going to get a laugh out of this, as static typing people, right? Because C++ kind of has a static type system. It's leaky as a sieve, but it has one. And so, and what happens is, see, you guys are all young and impressionable, or you're like me and you're old and impressionable, but you're in school, right? And in school, you get this sort of religion-free view of what you're learning, right? Because you're learning computer science or computer engineering or whatever. And then you get out into the industry and you're surrounded by these people who maybe don't have CS degrees, or maybe they got their CS degree from a school where they didn't have to take a programming languages course or a compilers course or a theory of comp course, and they somehow all they had to take was agile extreme programming, right? And so and these people, it's scary, but I mean it's seriously, even at a company like Google where most of the people there, I mean probably 30% of the hires are PhD. I think it is actually about 30-30-30, right? 30% PhD, 30% masters, and 30% undergrads, right? Which is actually pretty good. And then 10%, other. I have two guys that work with me that are brilliant that didn't even graduate high school, So, so these people come in and they get this sort of religion around programming language. And this is the reason that I started blogging at Amazon. It's actually why I started blogging, because people were like, oh, you need a C++ or Java or whatever their favorite variable substitution was. And I was like, well, yeah, but different languages have different sort of strengths, right? And if you learn a bunch of languages, it teaches you to think differently, right? I mean, there's things that you can express in languages like Camel and Haskell that they're very awkward in Java, say, right? And they're just like, well, I don't need that stuff, right? You're going to hear this. You're actually going to hear it. People are going to be like, well, I don't need that because I've never needed it before, right? It's this really bizarre, paradoxical, this mindset people get into. And so, anyway, I could talk all day about it, but I just wanted to get a feel. Who here, who knows Java, also knows some dynamic language? I mean, a loosely typed one. Python, Perl, Ruby. Yeah, most of you, right? Yeah. Frou-frou languages. They're fake languages, huh? Huh? Yeah, they are. So, that's kind of the reputation they have at Stanford companies like Google and at UW companies like Amazon, right? Where basically the big languages are C++. It's funny, usually there's C++ and Java, and they're about 40% and 40% of the programming staff, right? And then there's the 20% that have kind of consolidated around some other language. At Amazon, it's Perl, and at Yahoo, it's PHP, and at Google, it's Python, right? No, it's not Ruby. Who said Ruby? I thought you did. It's Ruby and sysops. Bless them. Ruby's a great language. But the problem, one of the problems is that C++ and Java were actually designed by people who didn't fail compilers class, right? And then Python and Perl and Ruby and JavaScript, right? Seriously, these people really made some boneheaded mistakes, and I'll talk about some of them. And their boneheaded mistakes make it very difficult to write a compiler, right? If you don't have lexical scoping, if you have dynamic scoping, so you have to actually search up the stack, up your call stack, there isn't a lot you can do, right? You guys know how lexical scoping works, right? Lexical scoping, you can actually pre-compute an address because you know exactly how many stack frames up your caller is, right? Because it's lexical scope. And so you can actually make it as fast as a local variable lookup. But with dynamic scoping, you got to go, well, do you have it? Do you have it? Do you have it? Right? So ELISP and Perl and all these languages, they started off with with a foundation that was it was meant to be easy for users, and unfortunately it didn't provide enough purchase for compilers. And we're going to be talking about some of those problems today. But it gave them a bad rep, right? Plus, they're just awful hacks, right? I mean, really, they are, most of these languages. Ruby seems kind of sort of elegant, you know, until you actually look, and it doesn't have lexical scope either. He just kind of faked it. So I could talk about that all day, too. We had this dude. We have this senior principal engineer at Google. His name is Mike Burrows. Hi, Mike. He's probably going to watch this. I probably can't tell the story. But he said some disparaging things about somebody who designed a programming language who eventually got hired. So that's the danger. You don't want to actually say anything. He said it on a tech talk that's actually videoed on our site. So it's not, he knows. Right? I'm sure it's like all water under the bridge. But I mean, even like I've said some things about Guido, right? You know, not as a person, but as a language designer. And then, you know, of course, he came to Google and like he listened to one of my tech talks and he came up afterwards and said, that was a very nice talk. And I'm just sweating. I'm like, I'm sorry. So he's like, oh, don't worry about it. So, you know, people are good about this. Because what happens is their language gets really popular, right? From marketing, basically. It's not from any sort of technical merit. And then what happens is like people are like, well, how come you didn't do this or that? And they're like, I don't know, and they go look it up in a book, and they're like, oh, that's how that works, right? And so eventually they teach themselves, and they become like these world-class compiler writers. Like Brendan Eich, definitely, like, you know, the JavaScript guy. You know, he came to Netscape to write Scheme for the browser. How cool would that have been? Not clear, right? It would have been like, it would have been, I mean, it seems kind of cool, but if you can imagine like a million web devs like hacking in Scheme, you're just like, ew. So anyway, they kind of like bait and switched him because he showed up and he worked on a Scheme, you know, interpreter for the Netscape browser. And then Bill Joy did some sort of backdoor deal with Sun where they were going to like license, they were going to use the name JavaScript, right? And this is unbeknownst to anybody like at Sun, other than the VPs at Sun and Netscape who did the deal, because I guess Sun was working on their own scripting language, probably just as bad. And they came to Brendan and they said, make it kind of like Java, right? Now imagine you've got Scheme, which is like this pure, beautiful thing that Guy Steele made like 30 years ago. It hasn't changed. And they're like, make it like Java, right? You know, and you have a week, because that's how long he had. And he was like, oh. He says he like, you know, retraced McCarthy's steps like, you know, like on his own. So anyway, he came up with JavaScript, which we'll talk about a little bit. JavaScript's an interesting language. It's I don't know how much I'll be able to talk about it, but I've decided I've done most of my programming in JavaScript for the server side at Google for the last year. And even after a year, I've been through the ECMA spec. I've written an interpreter that I'll talk about a little bit later. I mean, I know as much about JavaScript as your average Joe, and it's still got a lot of weird edge cases, right? And this is why companies don't let smarter companies like Amazon and Google, ones that want to kind of not have complete chaos in their engineering environment, they limit the number of languages to like say 3 or 4. It's usually C++, Java, and one scripting language, and those are the official languages, right? And it's because what happens is every language has this huge like space of dark corners that like only a few people know, right? And if you're using those in your code and like you've got to like debug some production problem, then people get irked. So anyway, so everybody knows that Java, the JVM, is like .NET. It can support multiple languages, right? Everyone knows it's a stack machine. It's not a register machine. Can anybody name a register machine? A virtual machine? Parrot. That's right. Is anybody here at Foo Camp this year? No? So I got invited to Foo Camp, and it's like really hot. Good Lord. If you go to Foo Camp, like bring lots of water and shorts and stuff. It's in the middle of some barren, horrible place in California called Sebastopol, where O'Reilly got some like cheap office space in the dot-com boom, dot-com collapse. So like, I'm at Foo Camp, and on the last day, there's this talk, and it's by the LLVM guy, Chris, I guess his name is, at Apple, and what's his name? Yeah. But the people there were like, it was unbelievable. It was Chris. It was the girl from Parrot, Allison Randall, right? She was representing Parrot. There was the Squeak guy from is Disney? I don't know. The guy who wrote the Squeak VM, Smalltalk, right? And there was the JRuby guy, and there was the John Lamb, the Microsoft Iron Ruby guy. And I mean, it was basically like, I can't remember who all was there. We were in this little tent in the parking lot. It was like basically, I mean, if a bomb had gone off, it would have just killed off dynamic languages in the industry. Because like it was everyone, right? And I was just listening. And And Chris was clearly the one who had thought the most about these issues, right? It was pretty funny because everyone else was really tied to their language, but he was writing a cross-language VM. And he asked this really innocent question that triggered the most insane firestorm debate. And it went on for 45 minutes, and then we had to break for dinner. And they're still at the dinner table just talking to each other. All he asked was, how does this work, right? Because we were talking about, everyone's well, multiple languages running on, the JVM or on Parrot or on LLVM or whatever, and pick your favorite VM. You could run them at the same time, right? Because you got, the interpreters running, and potentially they could call each other. And then maybe then what? Maybe, well, for example, one prerequisite for a JVM language for it to be useful is it has to be able to basically do anything that Java can do, right? So you have to be able to subclass Java classes and implement Java interfaces. You've got to be able to, call, using reflection, getters and setters, things like that. There can't be any sort of weird syntactic cases like static, initializers that your language doesn't support, or you won't be able to use it as a drop-in replacement for Java, right? And so Jython and most of these languages can do this to some extent. So you could imagine, well, what if you wrote a Jython subclass of a Java class, and then you wanted to subclass that in JRuby? Could you do it? Right? And that's, people were oh, yeah, we're going to solve this problem, right? The Parrot people were oh, yeah, they're all going to be interoperable. They're all going to have the same. And so he's how does that work? I mean, from a user perspective, right? And it just, everyone just blew up because nobody knew. I mean, clearly it was there's 10 years of research here, right? I mean, it was huge. And the Parrot people were trying to just smooth it over. Oh, it's easy, you'll just call. You just call each other. It's well, what if one of them supports keyword arguments and one of them doesn't? What if one of them supports varargs and one of them doesn't? What's the compiler supposed to do, right? So, anyway, it was a really interesting discussion. I wish I had it in video, but I didn't. So, how do you do this? Well, you can compile to Java and then run it through Javac. You can do a recursive descent parser. You can write a bytecode interpreter, or you can write an optimizing compiler. And we'll talk a little bit about it. So we have JVM languages because we can. All right. That's pretty much why, right? I mean, everybody and their dog has written a JVM language, right? Who here has written a JVM language? Even a small one. Yeah, see, we've got representatives in this room. Use his language. I'm marketing it for you. What's it called? Cool. Wow, that's cool. All right. So it's a good experiment to do, just to see just how horrible the Java bytecode is, right? Because, see, the thing is, Gosling was kind of onto something and kind of not when he and, who else made Java? Him and Bill Joy and I forget, right? They all got together and they made this VM, right? And they're yes, it's going to be a general-purpose virtual machine that abstracts away. And what it does is Java, right? If you ever look at the Java bytecode, it has, class construct, define class, and it has, declare public static final, int variable, right? And things like that. You actually look at the opcodes, and they're really closely tied. It's a register machine, so it's got, push and pop, and it's got, some support for that. But mostly it's Java, right? So what if you want to do something that Java doesn't support? Name a language feature that Java doesn't support. Yeah. How about one that... All right, so pointers are a little rough. Operator overloading, thank you. Yeah, I mean, I wanted one that some sane language actually supported, right? So sorry, did I say sane? I meant safe. The letter transposition there. Safe. All right. So, well, here's a bunch, right? Java's not type safe. All right, I'm sorry. I don't want to start a flame war until we're kind of close and I can run, right? But all right, so type safety, right? We've got Nice and Scala, which are kind of ML, Hindley-Milner type system based, right? And so they're much more type safe. In both of them, Nice and Scala, you can't get a null pointer exception unless you say, this can be null sometimes, right? There's a hole in the type system. All good type systems have holes, right? Who here really loves Haskell? Huh? Yeah, Haskell. Great language, huh? No holes though. No, actually, Haskell does have some though, right? You can get around the type system. I had this intern this summer. I forget where he was from. SUNY, I think. And he said, the problem with Haskell is people keep trying to turn it into a useful language. And he was all passionate about it, right? And I'm yeah, that's a bummer that they're doing that. But yeah, so Haskell does have a huge... OCaml. I prefer OCaml. Who knows SML or OCaml? One of the two. Ooh, they're nice languages, huh? Kind of fun, huh? So like, but OCaml, like, of course, is impure because it lets you, you know, kind of have boxing and stuff like that. But in any case, they are more type safe. If you can get your program to compile, they'll definitely have fewer like classes of runtime errors, right? The problem is this becomes this sort of brand that the mobs can like wave at you when you go to like industry. They're like, well, we have types. It's like, yeah, but you also have like array index out of bounds exception. You have the halting problem. Remember that? And they're like, well, no. You know, it's like, you know, there's situations like where you have user input, you know, and like at that point, you know, what can your type system really do for you, right? I mean, you have infinite types. You know what I mean? I mean, it can help, but people actually like, there's so much FUD, right? There's so much religion in the industry around languages, and so, you know, you say, well, you know, I want to use a dynamic language for this, and they're like, it would never work. It would crash and burn, you know, and well, whatever. So there's a lot of religious wars that go on at all these industry companies. You should stay safely in academia where there's no religious wars at all. So anyway, there's all these different dimensions that you can like choose to sort of focus on. It would be difficult to focus on all of them. And so what it becomes is this sort of a bunch of knobs that you can turn to choose which language you want to use, right? And unfortunately, Google had this great big knob, which was C++, which doesn't run on the JVM, last I checked, Java, Python, and JavaScript. Those were my choices. And so I wound up picking JavaScript. I'll talk about it in a little bit. So, yeah, compilers. Compilers are really interesting. When I took compilers in school, like, it was interesting from this sort of theoretical perspective. But you guys know the difference, like, when you've got a textbook and you've got to learn it because, you know, you're interested in it, and you've always wanted to know how video drivers worked or compilers or whatever, right? And you pick it up and you can kind of like, learn, or physics, right? Who here really loves physics? Electromagnetism, the Biot-Savart law, huh? Hands are like starting to go down, right? It's like, you know, when I was in physics, because it was a prereq, like I had to like use child psychology on myself to get myself to pay attention to the book, right? Because it was like I'd have to pretend that I was going to be a world famous physicist someday, that I really loved it, right? And then the book got more interesting, right? And what I found is if you have to learn something for your job or in order to get something done that you really want to get done, then like the book gets lighter, right? It's like you want to barcode scan it, right? And I was definitely not there with compilers. I was like, oh, this is really interesting. Yawn, you know, stack frames, right? Allocation. But you're completely surrounded by compiler technology, whether you like know it or not, and whether you like it or not. If you look at the tools for languages, almost all of these are compiler tools. Every single one of them, in fact. I don't see one here that's not a compiler tool. Maybe the profiler, but the compiler's probably going to have to generate some hooks for you, right? So like you got your front end tools, right, which require syntax tree, right, which is like, you know, to do your pretty printers, to do your style checkers, your linters, right, you know, and your IDE support, your automatic indenting and all that stuff, right? Or you could just hack it together with regular expressions. Who here would hack it together with regular expressions? Oh, no. No, you wouldn't. Yeah, unfortunately, that's what people wind up doing, right? And why do So this is actually, you know, when you go out into the industry and you ask people, you know, interview questions, you're like, what should I ask? Ask them, you know, what a regular expression is and, you know, what are the sort of limitations. Ask them if you can match, you know, XML with regular expressions, right? You know, nested. And then ask them why, right? And they go, you know. So I get really excited when I interview people from UIUC because, you know, you've heard about the Chomsky hierarchy and you can actually talk about, you know what you're talking about. All right, so anyway, it's a giant pile of work, which is why very few JVM languages actually have any sort of following at all. There's like probably 300 of them now, but they're not usable. I tried. I took the top 10 and I did this I did an implementation of Sokoban. You ever play that game, Sokoban? I probably should have done Sudoku, right? That's the other big like Japanese initiator-oriented game. Although Sudoku, it turns out, was actually invented by some dude in the United States in the 70s. That's another story you can look up online. So anyway, I did the Sokoban implementation in 10 different JVM languages, including Java, and kind of compared them and contrasted them. And most of them were like, it was just like pulling teeth. Even if it was a good language, there was like no documentation for it at all. And you had to sit down and, so please, like just please, if you plan on like writing the next big language, right? You guys are you're going to be the next like Larry Wall or I don't know, you know, choose your favorite language geek. Please write some docs for it. Right? That's actually why Perl got popular, right? Because it had the camel book and it was chatty and it was fun and like it like talked to you like a person. I mean, textbooks are pretty dry. It gets right down to it, right? There has to be just, I don't know why. I mean, they're getting better about it, right? I mean, they are, but still, they're definitely not the camel book. All right, so anyway, let's talk about these dynamic languages and like whether they can be fast or not, because this is one of the #1 FUD things is, well, it's going to be slow, right? Like, I programmed an assembly language for 5 years, okay? C++ was for wimps, right? Like, if statements were like this luxury, right? Because we had jump CX0, you know? And this is maybe not the smartest business decision that GeoWorks ever made, but they wrote everything in assembly language. They wrote the operating system, and they wrote the applications and the libraries, and they were competing with Microsoft. And they were actually a really cool place to do an internship and work full-time at the time. So we wrote everything in 8086. It wasn't 80x86, right? It wasn't like 8386 where we had protected mode. No, okay? It was 8086. 5 years, okay? And so like, you know, people are like, oh, you don't know, you're not a real programmer unless you program C++ bare metal. And it's like, no, right? So, you know, I feel justified in saying, no, I think I can like justifiably use JavaScript if I want to. And, you know, so they back down. And you know what? The funniest thing is, I don't think I've ever said this before, but you know why I got away with doing this crazy Rails port in JavaScript at Google? Because Google's got a lot of smart people. Like, I tried to use Ruby there when I first got there to do some prototyping for this business that we're trying to get in that required contact with external customers who didn't know what they wanted, and we didn't know what they wanted, and so we had to kind of iterate, right? So you want some rapid prototyping. And Google is built for industrial strength scale, right? They're like, your project will be impactful if it has 170 million users within your first year. And you're just like, per what? And they're like, per second. You know, and you're like, oh, you know, right? And they give you all this great infrastructure for doing this. It's really astounding, really. I mean, Google's kind of this opaque company, but when you go inside, you're just like, oh my God, they're going to take over the world, right? I mean, because they just got just unbelievable discipline there, right? You know, but it ain't set up for prototyping, right? I mean, it's just like hello world. It's just like 2 weeks. You got to put in tickets to get permissions to get the. They're like, we're going to run it on this cluster of 5,000 machines. You're like, it's hello world, right? You know, and so like I tried to seriously like I did this code lab when I first got there. Like I'm a noogler wearing my beanie cap, right? They give you this colored beanie, and like I'm doing the code lab. It's for Bigtable, right? Bigtables, are big. It's a big table as it turns out, right? That is really big, and so like I do the Bigtable code lab and la la la, and then like a year and a half later, I get a mail from this Bigtable team going, yeah, your Bigtable's running a really old version, and we want to. And I'm thinking, I'm not running a Bigtable. And I go look it up, and it's my code lab, and it's been running for a year and a half because I forgot to shut it down. I mean, that's pretty amazing, right? I mean, at Amazon, we couldn't get stuff to stay up for 10 hours, right? I mean, seriously, the distributed computing infrastructure is unbelievable, but they don't like Ruby. No Ruby, okay? That was just ixnayed, just right out the door. I'm like, what about for They're no. I was like, well, no, right? Rob Pike personally yelled at me, right? That's my claim to fame at Google. Rob Pike yelled at me, right? Like, no, you can't use it, So, yeah. And it wasn't because of Rails. They didn't care, right? It was because of Ruby, right? And in the fullness of time, I've come to understand that it's a good thing, right, that we've limited the number of languages. So what did I do? I picked one of the languages that I could use, and I ported Rails to it, right? Now, had I done that the day that I got there without having established any credibility, I probably would have been like, probably voted down, right? Or wouldn't have gotten this. So why did they let me do it? Because of my blog. If you ever want to have influence, right? Like, seriously, just start making fun of people in your blog, right? Because, like, some dude told me this in the bathroom at Google. I'm like, yeah, I couldn't believe it. They actually let me get rid of it. And he's like, yeah. I'm like, what do you mean, yeah? And he's like, they don't want you to ridicule them in your blog. And I'm like, oh. I thought it was a good, I actually thought I convinced them on my technical merit, and I had made this reasoned argument. And he's like, no, blog. I'm like, okay. So anyway, whatever works. So I did Rhino on Rails. There's the Rhino. Is that the ugliest icon you've ever seen? That's on the actual Mozilla website. Poor Rhino. All right. Why did they call it Rhino? Anyone know? Nobody knows. You know? That's right, because the O'Reilly JavaScript book had a Rhino on it. So when they did the Java version of it, they called it Rhino. I don't think it was originally called Rhino, because I think Norris Boyd, the guy who wrote it, was actually working at Netscape, like kind of down the hall from Brendan Eich, and so they were kind of working on it at the same time. And Rhino is actually a port of the C code base. So if you look at it, it reads totally like C code. I mean, really, it's like the closest to C code you've ever seen Java, right? It's all buffer allocations and while loops with little pointers and stuff. There's no it's not Java. It's really interesting, which is one of the reasons it's so fast. Interestingly, Norris Boyd, right? I was looking at using Rhino for our technology, so I mailed him. I just like looked up his, because he's like he's one of the committers to Mozilla Rhino, and I mailed him out of the blue, and I like, hi, I'm Steve Yegge. I work in the Google Kirkland office on this little project, and you want to work for Google? And he's like, first of all, you don't need any introduction. I'm like, oh. And because this is right after I published that blog where I was getting hate mail from everybody in the whole world about Agile. So anyway, he goes, and yeah, I'd love to work for Google. I'm like, okay. So like, I got him set up. He went down for interviews, and he had an amazing resume. And so now I bug him every time there's a bug in Rhino. Like, Norris, it doesn't work. So anyway, he's the one who's mostly responsible for all these really cool compiler optimizations I'm going to tell you about. All right, well, anyway, so this Rhino on Rails thing, it's real. I'll show you some code. Look, code. So this is server-side JavaScript. And it is, does anybody here know Rails? Ever done a Rails site? Couple? Not many? All right. So like, it's very declarative. So you wind up, declaring, I wish I had a little pointer at this point. But see how it says layout, Ajax, accept, blah, right? These are the names of methods, basically, right? That are down in the ... here. And so this is a class definition, right? JavaScript doesn't have conventional classes. I thought he was going to come give me a pointer, like the wish fairy. At which point I was going to say, I should have wished for $1 million, right? So, a null pointer? Where? Oh, a null pointer. I get it. Okay. Yes, it's a null pointer exception. And he threw himself up here. Okay. Somebody should have warned me. I get it. This is a geek crowd. Okay, good. Great. So we can talk geek stuff then. All right. So anyway, notice that this index function here is completely empty, right? There's nothing in it. That's all you need in Rails is just to declare it, in our case, in the actions hash here. And then you can hit the page, right? This actually caused some minor security problems in Rails. Like you could, for example, hit a URL and delete their database, right? Or you could hit a URL and fire up the debugger. And this was just over this summer, right? This is recently. And they put out this big security patch, and they said, you must upgrade to the security patch, and we're not going to tell you why. And everyone was like, well, then the hackers will know, but we won't. And they're like, well, we're still not going to tell you. And so it was just a huge fiasco. And so eventually they went and looked at the unit tests, right? And it was like, there's a new unit test to see if you were deleting the database. And they're like, aha, right? And so there was a big, they yelled at the Rails people about it and everything. So actually, that actually kind of leads into the slide that I just had up here, which is our thing actually kicks Rails ass in a lot of ways. It was kind of unexpected, but Rhino's way faster than Ruby, right? For starters, Rhino is actually compilable into Java bytecode. Okay, I'm going to take a segue here and maybe get a little ahead of myself, but I'm going to tell you a little bit about JavaScript's memory model and its execution model. Okay, it's a little bit wacky. Okay, first of all, normally when you make a function call, the compiler compiles code that will allocate a stack frame, right? And so there will be some sort of handshaking little dance for like pass values, the arguments, and the return values, right? And maybe some other information, right? There'll be a frame pointer and all that stuff. Did it all in assembly language at one point. All right. So in Java, and so when it's on the stack, it's on a hardware stack, right? So there's actually hardware instructions to like push and pop frames, right? So fast. Okay. And then so the stack is one of those regions of memory that your program just kind of has, right? And then you have the heap for all of your memory allocations, and it's slower, right? Because it needs to go to the typically needs to go to the operating system, unless maybe your VM is allocating a big block and then doing its own allocations. But then it's acting like a little operating system. But there's some sort of algorithm that has to happen. Have you taken OS? Yes? Please say you've taken OS. Good, right? It's probably required, right? Yeah, so you know that your heap can get fragmented, and you can ask for a block and have 50% of your heap left, but there's not enough space for your block, and so on and so forth, right? So all these issues require, computational runtime overhead, right? So the heap is a bit slower. Well, JavaScript stack is on the heap, okay? The way it works is, get this, right? When I make a function call, like I'm calling a method on some object, I create not one, but two objects on the heap. The activation object, which is going to hold my parameters, okay, and my return value, I guess. The compiler's going to take care of that. And then, this thing called the arguments object, which they added in because it's their way of handling varargs, basically. Like, you can declare any variables you want in a function in JavaScript, and then you can pass whatever. Okay? There's no checking. So you have to go to the arguments object if you want to like collect the varargs. Every single function call, method call, involves 2 method allocations. Okay? So it's slow, right? But slow, I believe, is the technical term for it. Okay? So, well, what can you do about it? Well, it turns out that if you don't have a lexical closure, okay, in the function, anywhere in the call chain, which you can determine lexically by looking, when the compiler's going through. Let me pull up this code here and I'll compile it for you. When you're, boy, we don't have any very deep calls here, but this server time call at the bottom here, when the compiler goes in and sees the this, right? It's like, ooh, that's a variable. That's the only one in here. It's kind of a fake variable in JavaScript, one that's really busted. But let's pretend it's a local, like an instance variable, right? So if you var x equals 6, right? And then you call a function that inside of this function, then it knows. It's keeping this basically stack of lexical scopes in and out, right? So at compile time, at parse time even, it knows, right, that you've got this lexical, whether you've got a closure or not. And if you don't, you can actually compile it into Java bytecode. Now, why can you not have a closure? Why can you only compile it into Java bytecode that uses the Java call stack and turns all of your activation record objects into local variables, Java instance variables or local variables? Why can you only do that if there's no lexical closure involved? Any guesses? Because Java doesn't have closures, right? Why? Because Java is stupid, right? I mean, seriously. I mean, like, right now, as we speak, this is something I've wanted to blog about, but it's so painful because I have so many like friends that are like intimately involved with this. Like, the Java community is trying to add closures to Java. Now, all a closure is it means you can refer to a variable outside of your lexically scope enclosing variable beyond the lifetime of the function, right? So if this thing returns a function that refers to some lexical variable, then it can look up the variable later. How does it do that? It's magic. All it does is it keeps a copy of the lexical stack, right? The call stack of just the lexical frame. That's it, right? Anywhere. Keep it on the heap. Keep it on disk. It doesn't matter, right? It just has to have it around somewhere. And it's not a very complicated like concept. But the Java community is trying to decide whether to. This is going to get propagated all around the internet. Steve Yegge said Java was stupid, as if that was the first time. But they're trying to decide whether to add real closures, right? Like per the Scheme programming language, Guy Steele and who else did Scheme? Sussman and Steele, right? Or stupid broken closures that don't really work, right? Now guess where the majority opinion is going right now? Yeah, 90% going to the stupid broken ones. Why? No. This is something I wanted to blog about for a while. So I'll tell you guys first, and then I don't have to blog about it. But you see, the thing is, you got in the industry, you're smart, and you know you're smart. Your friends are smart. You know they're smart. Your coworkers, by and large, they're pretty smart, except that one dude who made it on the team. Nobody knows how, right? But, if you go to Google, and then just everybody's just scary smart, right? But there's these other people that are not smart. And they might have to understand it. I swear to God, I hear this argument all the time. Well, we don't want to scare other programmers at our company who aren't really that smart. I'm like, who? And they're like, well, just programmer, new people, people coming up to speed. I'm like, new people are smarter than us, right? Like my friend Ryan Rawson, he says, everyone knows how a CPU works, unless you graduated recently. It's like, ow. Sorry, they don't. It's a long story. They don't teach as much in school as I would like to anymore. Anyway, you're going to run into this situation where like people are deliberately preventing you from using the full power of a language, like in the style guide, because these mysterious other stupid programmers who are there, except we can't actually name them because everybody we know is smart, might find it confusing. I swear to God, that's why. It's the most ridiculous argument I've ever heard in my life. So anyway, I'm a little bit off track here. Let me get to my slides. Will bring me back. So Oh yeah, I finished telling you guys how the call stack works in JavaScript. So Rhino actually does detect if there's a lexical closure, and it compiles it to Java bytecode. Now, how often do you actually have a closure? Not very often, right? I mean, realistically, it's probably in less than 5% of your code. It's really handy when you use it, right? But it's probably less than 5% of the time. When is it useful? It's really, I mean, realistically, it's when you're doing functional programming in JavaScript, when you're doing higher order programming, right? Like map. Everyone knows what map is, right? Map says, take this collection, this sequence, right, this infinite list, whatever, right? Well, hopefully not map on an infinite list, but unless it has a pause in it somewhere. But what you do is say, please apply this function to every element. But that's really hard for some programmers, right? Oh, don't get me started. Okay? In any case, map takes a function, you pass it a function, and it applies the function to each element. You can imagine writing a loop that takes the function and calls the function with each thing, right? It's not really that conceptually difficult, okay? Well, if that function that you passed in happens to be referencing one of your lexical variables, right? Especially if you call it like map later, okay, or map reduce, right? Then you need to capture the lexical state, and that's where the closure comes into play, right? And that's the only time when you need to actually maintain the activation record and do the slow way with a compiler. So if you look through Rhino, it's actually got quite a few optimizations. How many compiler optimizations are there? Total. Yeah, there's a lot. Yeah, how many correct ones are there? That's right. There's a lot, right? I mean, so when you say, well, it's an optimizing compiler, you know, it does like 5 optimizations, right? They're pretty standard ones, right? You know, the sort of control flow ones, you know, where you've got the bit set, you know, and you can do your DAG of your, or actually, yeah, I guess it's a potentially cyclic. And so it's not really doing that many optimizations, but it does some, you know, and it winds up being pretty fast. How fast is it? Well, we had this bug early on that lasted for about probably 5 months while a bunch of people were using my framework, where on every page load, the framework was reevaluating from disk, from the network, okay, off of a NFS mount, it was reevaluating the whole system, okay, on every page load, like basically rebooting the whole system, and nobody noticed for 5 months. And like one day I was doing some single stepping in our debugger, and I was like, how come it's loading all of our system files, right? Now, how could it be like that you could be like doing all this like loading of like probably 25,000 lines of JavaScript code, you know, plus all the Java bootstrapping stuff, and right, loading it all up on every page load from the network, right, and nobody noticed? Well, it's because web apps have this weird footprint, right? And the footprint is the database is really, really, really slow, okay? Or the persistence, the data store, whatever it is. It's always really slow. And I thought that wouldn't be the case at Google because our ads database is actually supporting far more transactions per second than Amazon's databases were. And Amazon thought that they had the most transactions per second of any database in the world. But it's still slow because there's a difference between throughput and latency. Who here has taken like distributed computing? You probably cover it in OS, right? Right? You can have like really great throughput, you know, just be cranking them through, right? Like Starbucks, you still have to wait like 3 minutes for your drink, right? So who was it that wrote that article? Starbucks uses optimistic locking. You remember that? That was a great essay. That was brilliant. That was in Joel Spolsky's first, you know, best software writing. I highly recommend getting that book. Read the best software writing, because Joel Spolsky basically cherry-picked all the best essays that he could find in like 2005. And the Starbucks uses, you'll never look at a Starbucks the same again. Yeah. So saying does not use two-phase commit is basically the same as saying uses optimistic locking. Two-phase commit is this thing you do where, like in distributed computing, where you have to do a transaction across multiple databases, where you basically go, okay, everybody, we're about to do a commit. You, all commit. And then they all go, okay. Oh, right? And they're like, whoa. Somebody had a problem. You roll back. And they go, roll back. Oh! And then you're like, okay, some of them rolled back, but some of them didn't, right? You know, and like, you know, you've got this sort of partial transaction, right? What happens if you have like a customer database here and an orders database here because Sun Microsystems came in and said, we can run your whole business on one box. And it turned out to be a lie, right? Ask me how I know this, right? So, so anyway, that's two-phase commit. Starbucks doesn't use it. Starbucks says, give us your money, and we'll give you a drink later, right? And you kind of believe it, right? And it works. It's great, unless they give you the wrong drink. But then they have their own protocols. Anyway, I'm really off track now. Unit testing is really, really, really easy in JavaScript, but you guys probably don't care. Have you guys got like unit testing religion now? Yeah. So like unit testing is like the ultimate answer to like the static typing camp. They're like, well, you know, the static typing people are like, well, what if you have errors? And it's like, well, we'll have unit tests. And they're like, and then we say, wait, you do write unit tests, right? And they go, well, yeah, we sometimes do, right? I mean, we're working on it, right? And you're like, yeah, is that your pager going off? You know, because you know, in C++, you know, they think that it's this like type-safe system, but it winds up crashing all the time with null pointers. So, anyway, if you use dynamic languages, you will be forced to use unit testing. That's just kind of the way it goes. This is a little diagram of the architecture. It's amazing that it could ever be fast, actually. We've got Linux, we've got Java, we've got Rhino, and a big pile of Java APIs. And we've got my stuff, which includes turning JavaScript into Ruby. Thank you very much. Because JavaScript is pretty much intolerable as a language, like just out of the box, right? I mean, it's barely tolerable, but I mean, like if you're used to a language that gives you like nice expressive, like a sort of an object-oriented view of the world, you know, with a string class and an array class. And JavaScript kind of has these things, but like it's very non-orthogonal, you know. Most of the methods don't work across them. So like I wrote like 6,000 lines in 3 days. I was just like, hey, everyone, would you mind if I turn JavaScript into Ruby? And everyone was just like, you know, I was working from home. And so I just burned out like pretty much the entire Ruby standard library. I'd like built into our built-ins. And it's beautiful. And the only reason we could get away with it was, see, JavaScript has this object class, right? Just like Java. But the object, you know, in JavaScript, things are open. It's like a hash table, all right? It has a property. Every object has a property list. It is a hash table, actually. But it's a hash table that's optimized so that if you have fewer than like 10 entries, it basically works like an array, right? And so you can actually go in and you can modify the built-in classes. You can say string.reverse equals function blah, and you can return the reverse of the string, right, if you want. And then it's available to all strings and string literals in your JavaScript program, right? It's called metaprogramming, although this is a really kind of weak, watered-down version of metaprogramming, right? Just like operator overloading is kind of metaprogramming, right? Who here has read Gregor Casales' sort of seminal work, The Art of the Meta-Object Protocol? Figured you had. So, right. So like he says you can look at a programming language as a set of features on this sort of line, okay? And the actual setting for those features, if you project them all into one dimension, right? Just like rating engineers. How good is that engineer? You know, ultimately HR wants to project them onto a good-bad scale, right? You know, and you're like 4, right? So it's pretty weak, but you know, it actually works for exposition purposes. You can say the actual choices for the language are this point in the middle of the line. And then you give the user these sort of hooks, metaprogramming facilities, to change the definition of the language and modify it until it diverges, well, arbitrarily from the original language. Although at some point when it starts looking like Perl, you really want to kind of back off a little bit, right? Trust me. Larry should have done that before he came up with Perl. So, and metaprogramming hooks can include things like changing the way, well, it's effectively modifying class, right? Which you can't do in Java. You can't change you can't change it to have operator overloading. You can't change the parser to introduce new syntax, right? You can't change it to have multiple inheritance, right? Introduce the diamond inheritance problem into Java. That'd be fun, right? And you can't do it because people freak on you. They go, oh, God, you can't change the way arrays work because I know how they work, right? Because everybody wants to learn one language and then just kind of like move on to their like, you know, their sort of business domain. They want to write APIs, right? So don't change the way array works. But in JavaScript, I mean, it's pretty obvious. Like if you don't have a string.startsWith and you're used to it in Java, then you kind of want it in JavaScript. I mean, that's metaprogramming that's okay, right? So it's kind of this gray, you know, this kind of sliding scale of like how much you want to do it, right? And what happens is you wind up having to document the hell out of it because you're effectively making a new language, right? Especially if they give you macros and you can change the syntax, which JavaScript 2.x, which will probably be JavaScript 3, is going to have macros. Hygienic macros, scheme style. Yeah, Brendan's on the warpath. So anyway, that'll be interesting, putting hygienic macros in the hands of a million self-taught web devs around the world. Can't wait. All right, so let's talk about the compilation stuff. Okay, first of all, JavaScript is evolving. So here's Brendan's warpath. I think it's kind of cool. I mean, everything that I see is I like it. But even hardcore JavaScript programmers look at it and go, you're doing too much, right? You can't say function XX. That's too much like lambda XX. Right? Right? Who here, did they teach you guys even talk at all about lambda calculus in any of the courses? Really? Oh, you guys are smart, right? They didn't talk about it at our school. Yeah, you program without the lambda calculus. It's true. Well, you just use very small numbers, because otherwise they're... Okay, so, well, yeah, so they're adding lambda. Actually, so I mailed Brendan, and I went, Brendan, you know, I love JavaScript and all and everything, but basically the identity function is 11 characters too long. It's function, and then the curly braces, and then return, and then a semicolon, right? He's like, yeah, we've gone around and around and around on this in the ECMA, and nobody wants to add lambda, right? And so what they did was they got rid of the return, right? So what happens is the parser comes along and goes, la, 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 yes, we're doing a function, expect a curly brace here, right? And when normally it would go barf, because that's what parsers do, because they're so smart, right? God damn it. If you ever write if you ever write a compiler, please make the parser smarter. Like, compiler writers, for some reason, seem to think that they're the boss, right? They're the daddy, and you're the children, and they get to, or mommy, and they're going to tell you how everything's going to work, right? And so what happens is they're like, well, obviously, you'd never need the comments at runtime, so we're just going to throw them out. Can you ever think of a situation where you might need your comments at runtime? Oh, like, for example, when you're trying to look up how things work, right? So that's why JavaScript has JavaDoc, which is a preprocessor. And whenever anybody adds a preprocessor into your language, you know they're getting into major hacking territory, right? Hacking around deficiencies of the language, right? Of course you want them at runtime. You want to be able to, like, introspect. I mean, look at all the introspection facilities that Java gives you and that C++ gives you now with RTTI, right? You know, they give you the ability to look up the class of an object and get a list of its methods, call the methods, right? Construct an argument list, and actually pass it in. But no, you can't see what the method does. Heaven forbid. I actually spit. I always used to laugh at professors who did that, but now I know why. So you get all carried away. So anyway, you can find holes in the syntax. You're like, you're looking at it going, okay, we admit that curly brace return x, semicolon, end curly brace is a little bit much, right, for situations where you just want a little one-off throwaway function that's just an expression. So they added these things called function closures. So basically, if there's no curly brace there, it's no longer a parse error. They actually parse an expression. They also added array comprehensions. Everybody loves array comprehensions from Haskell, right? Aren't they great? That's not what these are. These are Python array comprehensions, which are just a couple of loops, basically, right? You have an expression, where is it, x for x in my list, right? This just compiles into a for in statement, and then it unrolls the loop for you. And you can't do nested loops with them, for example, right? You can basically do one loop that has multiple variables being updated, but still, right? A little bit of extra syntax. And JavaScript doesn't have block scope, right? Which leads to some really surprising results, like you can use a variable before it's been assigned a value, and nobody complains at you. And what's the result when you use a variable before you've assigned anything to it? It's undefined. Undefined is this really wacky value in JavaScript that's kind of like void. It has like, but they have null. They have null and undefined, right? So like, and they compare equal, but they don't compare triple equal. Why people are starting to yawn. All right, if I get too into the details here, we'll have to get back to the Eclipse jokes. All right. So I already told you about this. Oh yeah, does everybody know what continuations are? Really? Oh, come on. You don't all know what they are. Who here, come on, be honest, does not know what continuations are? It's perfectly okay. Ha, you're dumb. I'm just kidding. No, that was totally uncalled for. Continuations they're not actually in common use. They're actually, what they are is they're a generalization of control flow. And they're this really cool pin-headed concept that nobody ever uses in practice, except for web programming, right? Because as it turns out, they're really handy. What they are is this sort of glorified goto, right? That's what their detractors kind of say, oh, it's just goto. It's not just goto, but the way I look at it is a continuation is like a save game, right? Like, you're playing along in it. Let's say you're playing along in a video game. Come on, you all play video games, yes? Ones that you can save, right? And you save, and what it does is it takes a snapshot of the whole universe, right? If you were in like mid getting your throat ripped out by some monster, right, and you go save, right? And then when you come back, you'll be there again, right? Okay? That's a continuation, right? Because what happens is at some arbitrary point in your function, you can say, okay, produce a continuation for me, right? And it remembers where you were in the function. It remembers the state of any internal iterator variables. It remembers the state of your local variables. It remembers the state of the call stack if necessary. So what does that mean? It means that the implementation is really simple. All you do is you take all your stack frames and you copy them onto the heap, right? And you point something to it, and that's the continuation. And then later you can restart. You can restart a continuation. So people don't like them much because what happens is you can restart, you can come back to a function that's already returned, and you can return it again and again and again as much as you want, right? Which leads to some really nice, programming models, but can also confuse people. Those people, right? The ones we don't name. So continuations are a really interesting example of a language feature that you can't compile to Java. There's no way to do it. There's no way to make a copy of Java's call stack. There's no bytecode for it, right? There's no opcode for it. So, well, you can kind of do it if you're managing your own call stack on the heap in the interpreter. So Rhino actually has two code paths. So Rhino has got this gigantic bytecode interpreter that is Rhino bytecode. It's JavaScript bytecode. So it's got like a continuation opcode, right? And then it's got this whole other code path that's that's compiled down to Java, okay? Java bytecode. And you got to pass a flag to say which one you're in, right? And you can even have mixed mode operation, which makes it a real joy to debug when it's in production and it's 2 o'clock in the morning and your pager went off and you're like, which mode were we running it in again? Because they're actually slightly different. But by and large, we run it in compiled mode, so we don't use continuations, which is kind of too bad because continuations are cool. Who here has actually used continuations for something real? You? Or is that a question? No. Is it a continuation passing compiler? Oh, yeah, well, call CC. Yeah, it's a common idiom in Scheme. That's true. Yeah. Yeah, it's an interesting programming model, but it just hasn't seemed to catch on for some reason. It's because it wasn't one of the Gang of 4 design patterns. That's my pessimistic answer. It has upward-only ones with exceptions. Right. Well, you have to do that with closures also. Well, maybe that's why Java doesn't have closures either. Yep. Right. So it's a performance optimization is what you're saying. Sorry, for purposes of the people who are watching this on film, the commenter said that Guy Steele pretty much invented Scheme, so you would think that Java would have continuations, but it didn't because Guy Steele was involved with Java. And it didn't because you have to box mutating variables that you've captured via continuation, and that's an expensive operation, and so they basically left them out along with closures, display closures, for performance optimization. And as a result, produced a generation of Pascal programmers, basically. Nothing wrong with that. Works for me. All right, so how do you do a JVM language? Well, the first thing everybody does is they do a really quick parser using regular expressions, or they use a parser generator, or they write a recursive descent parser. Now, in your compilers class, they will tell you all about parser generators and how cool they are, right? Because they're this declarative mini language that lets you specify what your grammar is, and then it will produce a parser for you, right? Nobody uses them, it turns out, right, in real production compilers. Now, I've used them for little mini languages and stuff. They're great, right? Like a little SQL-like language or whatever. But most people actually write recursive descent. And I actually don't know the answer to why they use recursive descent parsers. Maybe it's for error recovery, or because parser generators tend to generate bottom-up parsers instead of top-down parsers. I'm not sure. You ask all the old grizzled compiler guys, and they're like, parser generators for wimps, right? So that's the end of the story. You don't no idea why they don't use parser generators in Visual Studio or in the Java C or any of the standard compilers. No, it's all recursive descent. You can go look too. Maybe it's because they're easy, right? Conceptually, you're just like, okay, I'm about to parse a statement. The statement, if I see a while or an if or a switch, I know it's a statement, right? So I'll just look for a curly brace and boom, right? And you're off and running. So they're pretty easy to write. And they produce an abstract syntax tree that we then throw away because users could never possibly need that at runtime, right? Like, for example, if they want to like integrate it with their IDE so they can do indentation, right? Or like, you know, statement completion or whatever. So compilers always like create an abstract syntax tree that they immediately flatten into bytecode. So, but this is what most JVM languages do. And I actually wrote a JavaScript interpreter for Emacs. And it's kind of in progress right now, but that's about where it is right now. It works. It's a completely ECMA-compliant JavaScript interpreter, and I'm working on the bytecode compiler right now. It's really, really tedious. Anyway, then you can flatten it to bytecode. Why is bytecode better? Why do you flatten the? You know what Java does, right? Java compiles your Java code into a class file, which is flattened bytecode, right? And then it passes the class file to the JVM, and then it decompiles it to see if there's any security problems, right? Right? So why does it go to all the effort of flattening it to bytecode if it's going to? It seems like that's a very expensive step, and writing an interpreter that walks the parse tree gets you there faster, right? Well, the answer is you make it up in loops, by and large, right? The bytecode is one big array, right? And you can go into a loop, right, where all you're doing is reassigning the instruction pointer. So there's no method call overhead unless you happen to be calling code that's calling a method, right? But for the code that you've actually compiled, right, so the method is like sort of inlined there, you don't have to do all the basically, you're saving yourself the method call overhead, right? Which is probably pretty expensive, especially if it's a dynamic language like Elisp is, right? So if you have like a goto, you need a goto statement in order to make this work. You need a set jump, long jump, right? Whatever your language supports. So in order to do a real bytecode interpreter that's in a tight loop, right? But then you can get pretty good performance out of it. And then ideally you can do Java bytecode, right? Because that bytecode interpreter is written in C, right? And then I don't know, a bunch of optimizations you can do. Real call stack, turn function arguments into local variables, and then at that point you've got this sort of real thing that actual users will start bugging you about. You're going, oh, you know, it doesn't work. It's not documented, right? So then you add in all your user configuration and then you're done, right? And so the last thing I'm going to give you here, we're done, is how to compile yield. Everybody know what yield does? Yield is basically a continuation. Right? What it does is it produces something called a yield in Python. It produces this thing called a generator. So if your function calls yield like this one does, then the existence of the call to yield means that the return value of this function is not, say it's a little different in Ruby, because Ruby just like calls you back. It's like coroutines, right? But in Python and JavaScript, it returns a generator function that and then you call next, next, next on. And what it does is it pops you right back into the context of this function where you left off. Every time it calls yield, it's calling you back, right? It's coroutines. So what it has to do is it has to do exactly what we talked about before. Now you guys are armed with the knowledge of how to compile this to Java bytecode. The answer is you have to basically have this little object in the background that represents your continuation, right? You don't need full-blown continuations. That's what I wanted to do. I wanted to do the lame way. I was talking to Norris about it, and I'm like, we could use continuations, because that makes it really easy, trivial, right? Do it at the JavaScript level. And Norris was like, no, we're going to create a Java object that represents continuation, and we're going to. He's a really good compiler writer. So he went in, he got it working, and we were worried that there were going to be some edge cases where, you know, the bytecode verifier was going to have edge cases where we were doing things that, you know, there's things that you can do that are legal bytecode, and they work, and then you give it to the bytecode verifier, and it's like, oh, I think that's a potential security risk, so I'm not going to let you do it. Barf, right? And you just have to find some other way to do it. It's just one of those things around it. This is a problem with Java's bytecode, right? This is what Gosling was onto. Like, he was kind of onto something, but the problem is he froze it to Java's feature spec, right? For backwards compatibility, they can't introduce breaking changes into the Java bytecode. So like Java generics, which were like a huge deal because they added like parameterized types and you don't have to cast everything anymore, they're all static. They're all compile time, right? The Microsoft people have figured this out, and they're actually like doing a good job of breaking backwards compatibility. Or they did something to their VM, the .NET VM, so that they were able to add generics in a way that you can actually keep the information around at runtime, right? We done? Okay, we're done. Well, actually, this is the last slide. So anyway, I wanted to talk a little bit about yield so that to make the compiler guy happy. So JVM scripting languages are they're a big deal. You're going to be seeing them increasing amounts, and that's it. I'm done. Thanks.
So we have maybe a few minutes for 1 or 2 questions.
You guys are welcome to take off now if I've held you over and there's another talk. But I'll stick around for questions. Yes.
So I have to ask, why not Python and Python with Django?
It had to run on the JVM, so it was actually going to be Jython. And Jython's been dead since they hired Jim Huguenin at Microsoft in 2002. Now, Guido's mad. He's like, no, it's not dead. They've had like 1/2 of a dude on it. But like Rhino's like much better supported. It's bundled with a JDK. And so just when you looked at the support, the tool support, and the performance and things like that, the momentum, it was kind of a flip of a coin. I kind of preferred Jython as a language. Yeah. All right. Come on down if you got questions. I don't want to talk to this mic anymore.